Consider the curve equations bracket x squared plus y squared and bracket y squared equals 4x squared, where x is more than or equal to 0 and minus 2 is less than y less than 2. Show that the curve has no local maximum or local minimum points for x is more than 0. So it's asking for maximum or minimum points, so we can tell that we need to differentiate this equation and equate it to 0. And because there's y squared, you can tell that you need to use implicit differentiation. So first I'm just going to expand the bracket. So x squared y squared plus y to the power 4 equals to 4x squared. And then I'll just differentiate all of this with respect to x. So because there's x squared times y squared, we'll need to use product rule. So u equals to x squared, u dash equals to 2x, and then v equals to y squared, v dash equals to 2y dy over dx, because remember, implicit differentiation. So x squared y squared, this becomes 2x squared y dy over dx plus 2xy squared, and then y to the power 4, this becomes 4y cubed dy over dx equals to 4x squared comes 8x. So because we want to equate dy over dx into 0, we'll have to make dy over dx the subject. So I'm just going to group these together. So 2x squared y plus 4y cubed. So I'll move this to the other side also. So on the right hand side, we'll have 8x minus 2xy squared. And then I'm just going to skip a step, but yeah, I'm just going to divide. So all this over 2x squared y plus 4y cubed. And then we're equating this to 0, so that gets rid of the denominator. So 8x minus 2xy squared equals to 0. So 8x equals to 2xy squared. Okay, from this we can tell that if we cancel these, we'll get 4 equals to y squared, so y equals 2 plus minus 2. But we'll also be able to tell that x equals to 0 will also satisfy this equation. So it's asking us to show that the curve has no local maximum or local minimum points for x is more than 0. So these value shows there is a minimum or maximum point with these values, but they are outside of these ranges and domain. So we'll just say minus 2 is less than y less than 2, and x is more than 0. So no solution. And hence no local maximum or minimum points for x is more than 0 or minus 2 less than y less than 2.